Welcome back to our channel. If this is your first time coming across our video or watching our video, please don't forget to like, share and subscribe. And at the same time, if you find this video helpful, don't forget to drop your comment on the comments box below. In this video, I'm going to talk about hydrocarbon, and at the same time, I'm going to be focused on different points on hydrocarbon. But first of all, what are hydrocarbons? Hydrocarbons are basically the simplest form of organic compound that basically contain two major elements. The first one, which is the hydrogen, right? Or basically, the first one is always carbon, right? So hydrocarbon contain hydrogen and carbon, right? And then what will really happen is that they are the simplest form of organic compound, or let me say simplest type of organic compound that we have. And then it basically means they serve as the monomeric unit for other compounds. That is, other compounds are actually derived from what? Hydrocarbon. And hydrocarbon contain hydrogen and carbon. Generally, organic compounds contain carbon and hydrogen and oxygen at the same time. And any other element, like we have sulfur, phosphorus, we have halogens, then we have sulfur, phosphorus, we have what? Nitrogen, right? And some other trace elements. But basically, as far as hydrocarbon is concerned, it contains hydrogen and carbon. And they are mostly gotten from, let me say, petroleum source, right? Or just call them natural gas. You understand? They are gotten from natural gas, right? And at the same time, let me include crude oil as well. Exactly. So these are the major source of hydrocarbon. So from there, let's basically talk about the classifications of hydrocarbon, because it's very, very important for us to understand how hydrocarbons are classified. It's really, really important. Now, when it comes to classification of hydrocarbon, we are going to be talking about the classification of hydrocarbon based on the type of bond that are present in the structure of the hydrocarbon. And at the same time, we are going to talk about, let me say, we are going to classify them based on the three families that we have, families of hydrocarbon, right? We're going to talk about that one as well. And at the same time, we're going to classify them based on the two types of compound that we have, which are the aliphatic compound and at the same time, the aromatic compound. But in this case, we also have the aliphatic hydrocarbon and at the same time, we have the aromatic hydrocarbon. I'm going to explain everything in this stage, right? Now, let's just continue. Let's focus on on the classification. The first classification I'm going to be talking about is based on what? On the bond. Based on the bond that are found between the hydrocarbon, right? Or let me say that are found between the carbon to carbon atom, right? Now, based on bond, generally hydrocarbon are divided into two. The first one, which is actually the saturated hydrocarbon. We have the saturated hydrocarbon. I'm going to represent as HCS. That's saturated hydrocarbon. And at the same time, we have the second one, which is actually the unsaturated hydrocarbon. Now, when it comes to saturated hydrocarbon, what does it mean? According to the properties of carbon, carbon is made up of, let me say, it has the ability to form 4 bonds at a time, right? We know carbon can form 4 bonds at a time. Then in that case, it also have the ability to catenate, that is to form long chain. That is, carbon can form a bond with itself. That's catenation, to form a long chain. That's what we know. Then moving back to the ability to form 4 bonds at a time. Now, when it comes to saturated hydrocarbon are the compound whereby all the bond that are found between the carbon to carbon atom is fully occupied. That is, between this carbon and this carbon, the bond between them is occupied by any element. To be specific, hydrogen, as far as hydrocarbon is concerned. For example, let's consider the simplest form of hydrocarbon that we can have. Let's say we have hydrocarbon that contain a single carbon atom, and we said carbon can form a 4 bond at a time. Now, this bond here connects to hydrogen, and at the same time, this bond here connects to hydrogen. We also have hydrogen here, and at the same time, we have hydrogen here. Now, in this case, if you look at this carbon very well, all the bonds are fully occupied with hydrogen. So we basically refer this kind of compound to saturated hydrocarbon. And why is it saturated? That is because all the carbon to carbon atom, all the bond here, everything is fully occupied. That is, the bond between the carbon atom is occupied. And in that case, it means they are saturated in nature. That is basically saturated as hydrocarbon. You understand? So in saturated hydrocarbon, all the carbon will be fully occupied with bond. Now, if you consider this first carbon that is here, that you are seeing here, if you consider it very well, Let's count the bond that we have here. We have 1 bond here. 1, 2, 3, 4. That's 4 bond. As soon as this guy here, we're going to count this one. 1, 2, 3, 4. That's another 4 bond. This guy here, 1, 2, 3, 4. That's another 4 bond. This guy here as well, we're going to have 1, 2, 3, 4. That's another 4 bond. And this guy here, 1, 2, 3, 4. It shows that all the carbon that are present in this compound are actually occupied. All the bonds are fully occupied, right? So in that case, we call them saturated hydrocarbon. And one thing about saturated hydrocarbon I want you guys to understand is that they contain single bond all through. Single bond all through. That is, the bond between the carbon to carbon atom is basically single. That is, everything is what is single, as you can see in this case that you're seeing here. This case, this first case, all the bond between the carbon atom is single, right? And then one thing that happens is that why are they saturated, right? You basically say they are saturated because all the bond, carbon can form maximum bond of what? Of 4. So since all the bond between the carbon is is filled, right? Is filled with hydrogen atom, that basically means that compound is what? Is saturated, right? So that's basically what happened. And example of hydrocarbon that are saturated in nature, they are basically the one that are what? That belongs to the alkane family. Alkane family. I'm going to explain that one at the same time in just a moment. Now they belong to what? Alkane. So saturated hydrocarbon are basically referred to as what? Alkane. Now let's move on to the unsaturated hydrocarbon. Now in the case of unsaturated what? Hydrocarbon, carbon have the ability to form 4 bonds, as I said earlier, right? It has the ability to form 4 bonds. And what it means is that in the case of unsaturated, whenever the bond within the carbon is not maximum filled, that is, it is not filled up, right? That is, all the bond between the carbon atom is not filled up. That basically means the compound is unsaturated. So unsaturated hydrocarbon, they contain less than 4 hydrogen atoms on a single carbon. But although we don't have unsaturated hydrocarbon with just a single carbon atom, basically the simplest that we have is one of the 2 carbon atom. Now between the 2 carbon atom, you now have something like what? Like double bond, right? So what it means is that since you're having double bond here, it basically means this compound is unsaturated. Why? Because it is not all the bond that carbon do not use all its bond. You understand? That's basically what it means. So in that case, it's basically say unsaturated hydrocarbon, they contain one or more double bond. As well, they can even contain triple bond at the same time between carbon to carbon atom. That's basically unsaturated hydrocarbon. And again, saturated hydrocarbon contains just a single bond. Unsaturated hydrocarbon can contain, we have the double bond, right? And at the same time, it can contain what? Triple bond. That's basically what it means. So in the case of double bond, example of hydrocarbon with double bond, they belong to what? Alkene family. While that of triple bond, they belong to what? To alkyne family. Right? That's basically what it means. Now let me just kind of give you some example, or basically once we get to alkene, and alkyne, I'm going to explain in details. And I'm going to be giving you an example and the uses of these hydrocarbons. But for now, when it comes to saturated hydrocarbon, we have they contain single bond. When it comes to unsaturated hydrocarbon, they can contain double bond or what? Or triple bond. Right? So that's basically what it's mean. Then the next thing I'm going to talk about is actually to go ahead and explain explain the classification based on the compound. Right? The structure of the compound. We have the aliphatic hydrocarbons, that is hydrocarbon that belongs to aliphatic compound, and at the same time hydrocarbons that belongs to aromatic compound. You understand what I'm saying now? So basically, aromatic compound like benzene, they are part of hydrocarbon. You understand? But they are aromatic due to their resonance nature. They have the ability to resonate, like to form a cyclic structure. You understand? Most of them are referred to as almost all of them, they are referred to as arenes, right? Arene, because they have double bond within the structure. You understand? That's why they are called arene. Now let's just go ahead and talk about the aromatic hydrocarbon. Now let's go ahead and talk about another classification, right? So in this case, I'm going to be classify hydrocarbon based on the type of compound they belong. You understand? On the type of compound. On the type of compound they belong to. You understand? Compounds they belong to. And generally, as far as organic compound is concerned, will you guys agree with me? We have aliphatic compound and aromatic compound, right? Then in this case, I'm going to be classifying hydrocarbon that belongs to an aliphatic compound, right? We are going to have aliphatic hydrocarbon, right? They belong to aliphatic compound, and at the same time, we are going to have the case of aromatic hydrocarbon. That's going to be hydrocarbon, right? So when it comes to aliphatic hydrocarbon, they are hydrocarbon that can either be what be, let me say, be straight, or they can what they can be branch. So this classification will basically be based on, let me say, the structure of what of the hydrocarbon. The structure of hydrocarbon. We can have the straight form, and at the same time we can have what the branch form. For example, let's say I'm having hydrocarbon, and this is the carbon, right? And as you can see, everything here is what is in straight form. That shows that this hydrocarbon belongs to what to straight chain aliphatic what hydrocarbon. Then the next one is that if I'm having the one that is kind of what of branch, look at this case, is branch, right? So something like this, we have a branch chain here, right? It belongs to what to branch chain hydrocarbon, right? That's basically what we have. Then another one, typical type of hydrocarbon that we can actually have is those that are cyclic. Apart from straight, branch, you can have those that are cyclic, right? For example, let's say I'm having something like this. It is cyclic in nature. And let's simply say I'm going to write this guy here in such a way that I'm going to have it somehow like this. So this is cyclic form. And at the same time, I can have something like this. Look at this. I'm going to have something like this. It's also what is cyclic form. They belong to hydrocarbons, right? They belong to hydrocarbon. Don't forget that there's going to be hydrogen here, but I don't include it because I don't want to go ahead and then let's just say I'm including this. So this hydrocarbon, right? And this kind of hydrocarbon, they are basically cyclic in nature. They are cyclic hydrocarbon. This is branch hydrocarbon, and this is straight chain hydrocarbon. So these are the classification that we can actually have. Then the next one I can have is actually what's the case of aromatic hydrocarbon. So when it comes to aromatic hydrocarbon, they are basically cyclic in nature. You understand? They are commonly known as what? As arenes, right? And there is also other name for aliphatic hydrocarbon, but I'm going to explain those names when we get to alkane, alkene, and alkyne. For example, now alkane, we have paraffin, right? But once I get to that side, I'm going to explain the other names. But for aromatic hydrocarbon, they are commonly known as what? As arene, right? And then one thing that happens is that in this case, we don't really classify them, or we don't really name them based on the number of carbon atom, because we agree that the simplest aromatic hydrocarbon that we can have is what? Is benzene, right? Benzene is the simplest. And then benzene has structure of something like this. It has this kind of structure, right? We have something like this. We are going to add bond here, you leave this space, put bond here, leave this space, put bond here, right? This is a typical example of aromatic hydrocarbon. It contains hydrogen and carbon. That's why we call it aromatic hydrocarbon. But they belongs to arene family. And that's because they have double bond that can resonate anywhere in the compound. It can be here, it can be here, it can be anywhere in the compound, right? So that's the reason that you can draw the structure of benzene in this way, right? You can always draw it in this way, something like this. That's basically the structure of benzene. Now, based on the number of benzene that are present, we have different types of aromatic hydrocarbon, right? We have aromatic compound that contain just a single benzene ring. We have those that contain 2 benzene rings. We have those that contain 3 benzene rings, and so on. But once I get to aromatic hydrocarbon, I'm going to explain all these in details, right? And another thing I want you guys to understand is that unlike the aliphatic hydrocarbon generally, they have their own structural formula, right? Example, we have alkane. Alkane has its own general formula. And at the same time, alkyne has its own general formula. But when it comes to aromatic hydrocarbon, they do not have any general formula, right? There's nothing like general formula when it comes to aromatic hydrocarbon. They do not have general formula, because they are made up of repeating unit of benzene. We have a benzene ring like this, and at the same time, we can go ahead and have something like this. Let's say we have a benzene like this, right? Another benzene can fuse with it, right? Then another benzene at the same time can go ahead and fuse with it, as you can see. So we're going to have something here. So this contains 3 benzene ring, right? So that's just it under this aromatic hydrocarbon and so what? Aliphatic hydrocarbon. So these are the 2 classifications I'm going to be giving you. I'm going to give you guys, because I believe generally all other types of hydrocarbon that we have actually fall under classification based on the what? Based on the bond, which is unsaturated hydrocarbon, and also what? And also basically saturated hydrocarbon. And then based on what? On the structure of the compound. Let me basically put it like this. On the structure, here I'm going to have structure of the compound. You understand? So we have those that belong to aliphatic hydrocarbon, and those that belong to aromatic hydrocarbon. So we have 3 types here. We have the straight chain hydrocarbon, branch chain hydrocarbon, and cyclic hydrocarbon. Right? Cyclic hydrocarbon are basically referred to as cycloalkane, cycloalkene, cycloalkyne. They are cyclic in what? In nature. They are cyclic. And as you can see, this is a typical example, right? Then in this case, this is 1, 2, 3. You basically call it cyclopropane. Cyclopropane, and I'm going to explain the naming very well. You understand? I'm going to explain it well in a separate video. So this cyclopropane, this cyclo simply means it belongs to what? A cyclic compound, a cyclic aliphatic hydrocarbon, right? So in the case of aromatic, we have what? We have the reason why aromatic are actually treated specially is because they have some kind of what? Of properties, right? They have some kind of properties, and at the same time, they are much more stable compared to aliphatic hydrocarbon. They are more stable compared to aliphatic hydrocarbon. They have resonance activity. That is, the bond can actually resonate in between the structure. You understand? That's the reason that they have, they are classified separately. You understand? They are stable compared to aliphatic hydrocarbon. So that's basically what is happening here. So that's just it. I'm going to end this video now. Then I'm going to talk about alkane, alkene, and alkyne in a separate video. But generally, before I end the video, let me basically explain the importance of hydrocarbon and at the same time the properties of hydrocarbon. It's very, very important. Let's go ahead and talk about the properties of hydrocarbon. And in this case, when it comes to properties, I'm going to divide them into two. We are going to have the physical properties, and at the same time, we are going to have the chemical properties. But I'll kind of explain the physical properties better, and when we get to alkane, alkene, and alkyne, they are the families of hydrocarbon that we have. You understand? So now let's just come back here and basically talk about what we actually have here. Now, when it comes to properties of hydrocarbon, I'm going to talk about the boiling point, right? The boiling point, and at the same time, I'm going to talk about the melting point, right? It's very, very important. Then after talking about the boiling and melting point, I'm going to go ahead and talk about the solubility of hydrocarbon, right? Because it's very, very important for you to understand how soluble hydrocarbon is. Then at the same time, we're going to talk about the reactivity of hydrocarbon. Although this reactivity, I'm going to talk about it better once we get to alkane, alkene, and alkyne, right? I'm going to talk about it. Then the next one I'm going to talk about is actually, let me call it flammability. You understand? Flammability. That is flammable. The ability of a compound to burn in the presence of fire, like to burn. You understand? To burn. That's basically flammability, right? So, and I'm going to talk about it. And when it's come to boiling and melting point, right? Now, there's something I always talk about when it's we always talk about in organic chemistry, and then it's basically homologous series, right? Homologous series is basically series of compounds that differ between each other by just a single carbon and 2 hydrogen. That is basically what homologous series are. Homologous series are generally they are actually, let me simply say, they have the same kind of chemical properties, similar chemical properties, but kind of different physical properties. But when it comes to boiling and melting point, now an hydrocarbon with what? A single carbon, right? A single carbon, 1 carbon atom, 2 carbon atom, 3 carbon atom, 4 carbon atom, 5 carbon atom. We generally have different boiling and melting points. And that's because that's the reason why that whenever we are going from the top here, which is 1, down to this side, right? The boiling and melting point of hydrocarbon will increase, right? So as there is increase in the carbon to carbon atom that are present in a compound, there will be increase in their boiling point. That is, the boiling point of carbon 1, that is any hydrocarbon with carbon 1, will be different from that of 2 carbon atom. Will be quite different from that of 3 carbon atom. So as the carbon atom increases, so also the boiling and the melting point is going to increase. So also there's going to be increase in the boiling and melting point. Right? So that's basically what happened here. So generally, I'm going to come again. Whenever there is increase in the carbon atom, right? Down the homologous series, increase in carbon atom increase represents, it simply indicate that there is going to increase in the boiling and the melting point. Now, when it comes to solubility of hydrocarbon, now here this is what I want you guys to understand. When it comes to solubility, since hydrocarbons are basically organic compound, they tend to be insoluble. They are insoluble. That is, they cannot dissolve in a polar solvent. Whenever we have a polar solvent, organic compound like hydrocarbon, they tend to be insoluble. For example, whenever we have a solvent like water, right? Organic compound like what? Like ethane, right? Like propane, any hydrocarbon, they are insoluble in this compound, in this solvent that you are saying here, which is actually what? Water. Water is a polar solvent, right? And then organic compound like hydrocarbon, they are generally what? Insoluble in a polar solvent, but soluble in non-polar solvent. An example of non-polar solvent, we have what? We have ether, right? We have ether, we have ethanol, right? They are example of what? Of non-polar solvents. So hydrocarbon generally, most of them are soluble in what? In non-polar solvents like ether and ethanol, but they are insoluble in what? In polar solvents. That's what is happening here. Now, when it comes to reactivity, this reactivity is best explained when you get to alkene, alkene, and alkyne, but I'm going to talk about it, right? So when it comes to reactivity, reactivity basically try to explain how reactive an hydrocarbon is, right? Now, generally, as far as saturated and also unsaturated is concerned, right? Now, when it comes to saturated hydrocarbon, they are less reactive compared to unsaturated hydrocarbon. And the reason why is because all the carbon-carbon bond, everything in saturated compound is fully occupied, right? And in the case of unsaturated, it is not fully occupied. So that simply means saturated hydrocarbon is going to be kind of less reactive compared to unsaturated hydrocarbon. And don't forget, we have two types of unsaturated hydrocarbon. Yes, of course. We have those ones of double bond and those ones of what? Of triple bond. Those ones that contain just double bond and those of what? Of triple bond. The case of triple bond is kind of highly reactive compared to that of what? Of double bond, right? So the case of saturated, which is just a single bond, it is less reactive. So that's basically what I'm going to talk about when it comes to their reactivity. Now, when it comes to flammability, flammability simply means ability to conduct fire or to burn. You understand what I'm saying? In the presence of fire. That is basically flammability. And most times, if you check the use of hydrocarbon, most of them are used as fuel. And most of them are gotten from the natural source like the crude oil, the petroleum. You understand? So this actually contributes to their flammability ability, like the flammability nature. They have the ability to burn. And in that case, what it means is that all hydrocarbon, they are flammable. You understand what I'm saying? They are highly flammable, and that's the reason why that they are used as as fuels. You understand? So that's just about everything about the properties. And when it's now come to importance of hydrocarbon, just know that hydrocarbon, they are basically used in energy production. They are using in energy production. That's one of their uses, their importance. You understand? Like in nature, their importance in nature, they are used as energy production, right? We have energy production here, right? Then at the same time, they are used as due to their flammability nature, they are used as petrochemicals. You understand what I'm saying now? By petrochemicals. You understand? They are used in petrochemicals industry. They are basically classed as petrochemicals. You understand? Then at the same time, they are used as fuels due to their flammability nature. They are used as fuels, and at the same time, they are using in industry that has to do with manufacturing of plastics, manufacturing of nylon. You understand? Hydrocarbon are basically used as in the production of chemical let me say chemicals like nylon. You understand what I'm saying? Like nylon, we have at the same time some industry actually makes hydrocarbon to produce. We have something like we call the lubricants. You understand? And also we have waxes. You understand? Like waxes. You understand? They are used to produce waxes. In the case of paraffin, they are used as to produce waxes. We also have lubricants. So that's basically the importance of hydrocarbon that we have. Now in my next video, I'm going to explain alkane, alkene, and alkyne. I'm going to explain their properties and I'm going to explain them in details. And at the same time, I will try to talk about the homologous series. So that's going to be the end of this video. If you enjoyed this video, don't forget to like, share, and subscribe. It's very important. Thanks for watching.